Right. Good morning to all of you. Welcome you guys. Welcome you all. Yes. Welcome you guys. Welcome you all. First of all, do comment करके बोलिए now. Is the audio videos clear to everybody? Do comment करके बोलिए now here. Is the audio videos clear? Yes. Chalo. Let's continue our discussion. First of all, you can have a look at now here. Now, Unacademy subscription that is just 8,999 only. You can start your serious preparation with the Unacademy to achieve your dream goals. Just 8,999 rupees only Unacademy subscription. Not 60% of discount मिलेगा, इसके साथ फ्री एक्सटेंशन भी मिलेगा आपको. फ्री एक्सटेंशन भी आपको मिलेगा. So you can use this offer which is applicable for till 15th of June only. Utilize this opportunity before it going to expire. You can use the code of BVReady and to avail these great opportunities and great learning experience from the top educators. Now we are starting a new batch. We are starting from 12th June से नया batch शुरू होने वाला. So this means and the two subject digital and then EMFT is running. You can find the top educators team आपको एक साथ मिलेगा. And so the top educators this batch is for 2028 के लिए. 2028 के लिए batch so 12th June से शुरू हो गया. So you can see this thing digital and EMFT is running. So these are the Unacademy Gate 2026 rankers from Unacademy team का. So ESC 2025 rankers. ESC 2025 का rankers. Now, we do offer the two subscription. One is a plus वाला, the other one is a iconic. प्लस में आपको क्या चीज मिलेगा? टॉप एडुकेटर्स क्लासेस मिलेगा, लाइव डाउट्स and evaluated test series, structured courses, live test, unlimited access. आइकॉनिक में एडिशनली पर्सनल कोच भी मिलेगा एंड फिजिकल नोट्स भी मिलेगा एंड आस्क ए डाउट फीचर्स आल्सो. And do join immediately to have a great learning experience from the top educators. So have a great learning experience. Let's crack it. Yeah. Chalo, let's continue our discussion. The last class we have discussed some problems now here. Now we'll continue some more problems in today's class. Then we did. Right. Take the next one. 11th one. See the 11th one, what they're asking here. So they given this AC ammeter wire, they're asking to find the reading. So this means they're asking to find the current, they're asking to find RMS current now. So yeah, you tell me now what will be the RMS current? IRMS, yes, which will be equal to, this is square root of, so this is I naught square by 2 plus what tell me now here? I naught square by 2. Okay. Simply we did now here. So this is option A. Simply it will come to be I naught. I naught by root 2 will come. Next. An alternating current is given by its RMS value. Yeah, so same formula we can apply now here. IRMS. What is this RMS value? Tell me. That is square root of, that is what are 10 square plus 42 whole square, 42 by 2. So which will come to be a what element of 100 plus what element of 21. So 121. So 121 square root, which will be equal to how much now? 11. But 11 now, but no option. That is 11 amperes. This could be 11 amperes. Correct it. I'll correct this thing. Whatever the mistakes are there, I will update the things. Next, an alternating voltage is applied to a purely resistive load of 50 ohms. The time taken for the current to rise from half of the peak to peak value. Half of the peak to peak value. Anyway, so this current does not depends upon what I mean of here, this values. We can simply write as current I of t, which I can treat as what tell me now. This is I naught into, but it will depends upon the harmonic term and frequency. So this is what you tell me now, 100 pi t. Right. Now they given this time taken to rise from half of the peak to peak value. Half of the peak to peak value means what? Tell me, when t is equal to t1. So this current they are saying it as half of the peak value means what? Tell me now, I naught by 2. When t is equal to t2, this current I, which is equal to what you tell me now, this is I naught. Half of the peak to peak value. We can put this value now. So this is, we have, this is I naught by 2, and which will be equal to I naught into sine of, how much now here? 100 pi t1. So this I naught will get cancelled. So which will come to be a what term now here? Sine 100 pi t1, which is equal to 1 by 2. 1 by 2. That means what we can say now, 100 pi t1, 100 pi t1, which is equal to what we can say now, this is pi by 6. 30 na? So this pi will get cancelled. So will come the t1 value, how much now? 1 by 600 seconds. Next they are asking the peak value. Means that is I naught, which is equal to I naught into what we can say now here, sine of 100 pi t2. So I naught will get cancelled. So that means what I can say now here, sine of 100 pi t2, and which is equal to 1. Then we have 100 pi t2, that should be equal to what you tell me now, pi by 2 now. So that means t2 will come to be a 1 by 200. That is 1 by 200 will come. From this we need the time interval now. So this time that is delta t, which is equal to what we can say now here, that is t2 minus t1. So how much this delta t will come, which we can say now 1 by 200 minus 1 by 600. So which will come to be what? Tell me now, 600 is a LCM, and so this value 3 minus 1, that is 2. So that is delta T, which will come to be a what, tell me now? 1 by 300. 300 seconds. So from this we can write as delta T as what, tell me now? That is 3.3 milliseconds. Okay. Next one. Now the sinusoidal voltage is given applied to a pure inductor. They ask him to find the current. Yes, what is the current I of t, and which is given as what we can say now V of t by inductance reactance. So here impedance we can say now Z. So it should be equal to what, tell me now? 100 sine of 400 t by Z. Z is equal to what, tell me now? J omega L. Then we can say now this is I of t, which will be equal to 100 sine of 400 t by, that is J omega value how much now? 400, and L value how much now? That is 2 into 10 power minus 2. Now simplify it. Minus 2, this is will get cancelled now here. So 2 into 5, 10. So means 1 0 will get cancelled. So that means how much will come this I of t, which will come to be, and this is minus J10 into what I can say now here, sine of 400 t, and do simplify and get it. So that means we'll get it as I of t, which will be equal to 10 sine, or we can keep the minus as it is. This is sine of what we can say now, J means 90 degrees now. So this is 90 plus 400 t. Now we can say now sine 90 plus theta, which coordinate? Second coordinate. Second coordinate sine, yes, positive only. Sine will become cos now, cos of 400 t. So this is minus 10 cos 400 t. Option B. Next one. Now they given the EMF and current. They ask him to find the power. So this power P, which will be equal to what I can say now here, VRMS IRMS into cos phi. Cos phi is equal to 0. Phase difference is 0. So that is P VRMS means what, tell me now? E naught by root 2. IRMS is I naught by root 2 into what we have, tell me now? This is cos 0. So P value how much now? This is 1 by 2 into E naught into I naught. The axis rotation is perpendicular to the field. If the total resistance of the circuit is R, then mean power generated per the rotation is, actually this is related to EMFT subject now. Okay, uniform magnetic field means a wire in the form of semicircle of radius small r rotates about the diameter with an angular velocity omega. Okay. The axis of rotation is perpendicular to the field. Total resistances are, they asked to find the power. So means what we can say now here. So it is rotating. So power generation P is equal to what we can say now here, due to the rotation, that is NBA omega. The power which is equal to what, tell me now? NBA omega rotation. This is the EMF. EMF. So this is E. This is EMF, which will be equal to NBA omega. So N value not mentioned, 1 we can consider. B into A, they given it as area. They given semicircle now. Semicircle area is how much now? So that is pi r squared by 2. Pi r squared by 2 into omega. This is what, tell me now here? EMF. Then we need to find what, tell me now, current we need to get now here. So this is I, which is equal to EMF by resistance. That is I is equal to SB pi r square omega by what, tell me now, that is 2r. So the power is what, tell me now here? I square into r. Okay, here NBA omega into this is sine theta we have, and this is what tell me now sine theta. Here I can directly use this thing as VRMS formula I can use. So the power is what we can say here, VRMS whole square by R. VRMS, which is equal to 1 by R. VRMS means what, tell me now here? That is B omega pi R squared by 2 to yes VRMS by VRMS. What is the VRMS value? We'll find first of all. VRMS is equal to V naught by root 2. So that is here by root 2 also will come. So this is in root 2 for this whole square. So how much is value? Tell me now here. That is B square omega square pi square r power 4 by that is r into 8. This is the power. Check the option now. Yes, so which we can arrange it as power, that is B omega pi r square whole square by 8r. So 16th one, which will be equal to option B. Next one. An alternating current cannot be measured by DC ammeter because why the alternating current is not measured? Average value of current per complete cycle is 0. Yes. Average value of A. So here AC current is how much? 0. Next. A bulb and a capacitor are connected in series across an AC supply. Okay. A dielectric is then placed between the plates of capacitor, then glow off a bulb is. Now here a bulb and a capacitor. These are connected in series. In series to some AC supply they connected. Now what they're saying here, this is a bulb B. When they place a, so in this case, we can see what happens to current, we'll see first of all, and thereafter we'll see. Now here capacitance is given as what we know, epsilon A by D. When initially it is a medium is a air, epsilon is epsilon naught. When we have dielectric is there, so then it will becomes what? Tell me now here, some K epsilon naught A by D. Then as a result, what happens? You tell me now here, capacitance value increase. Because of this capacitance value increase, then what happens? You tell me now, reactance. So this is now impedance of capacitance is what? Tell me now. That is 1 by 𝐂𝐴𝐶 now. So as the capacitance value increase, impedance of capacitance decrease. Then impedance decrease, here the power current will be more now. Current will increase. If the current will increase, bulb will glows with a more power. The power equal to what I can say now, this is I square into R, let us say resistance of a bulb. Current increase means power also increases, so that's why bulb glows increases. The glow of the bulb increases. Okay, capacitance increase means the reactance decrease, then current increase. Thereafter, power will increase. Okay, next one. When a coil is connected across 20 volts DC supply, it draws a current of 5 amperes. When it is connected across a 20 volts 50 Hz AC supply, it draws a current of 4 amperes. The self-inductance of the coil is connected to a DC. So option should not give. I'll change this one. There should be, we need to get the inductance value, we need to calculate. So they given it as a coil is connected across. So here we have the inductor. Coil means it will contain the inductor and a resistor. Yes, which is connected across initially DC supply they connected. The DC 20 volts. This is the inductor and this is a resistor. When we apply the DC case, how the inductor will behave for the DC supply? It will behave like a short circuit for DC. Reactance frequency 0 now, that is reactance is 0. Now, so this DC will behave like what? Tell me now, for DC inductor behave like a short circuit. Then we have this current I. Then what is this current I, which is equal to what? Tell me now, 20 by R. How much is 20 by R? They given as a 5 amperes given now. That means R is equal to how much now? 4 ohms. We got the resistance, we got it. Now what they did now here, now AC supply they connected. For the same combination they connected AC supply they connected. AC supply having some frequency given. So resistor is also present. Now this is L and this is R. Now this is 20 volts AC and frequency is 50 Hz. Now in this case, this current they given as a 4 amperes. Yeah, you can tell me now here this current. Here the reactance is then a resistance value, we got this value 4. So this is Z is equal to what? You tell me now. Z is equal to R plus J omega L. So this R value, how much you can see now? So this is 4 plus J omega, this is 100 into L. J omega L, R plus J omega L. So the impedance, this magnitude we can calculate now here. Okay, fine. So this is I value they given us. What you tell me now? So this is 20 by Z, that is mod Z. So from this we can get this mod Z value as this current is given as a 4 amperes now. So this is 20 by 4, which will be equal to 5 ohms. This mod Z means square root of, that is 4 square plus, what tell me now here, 100 L whole square, that equal to 5. Now it is 4 square plus 100 L whole square, and which is equal to 5 square na. That means what we can say now here, 100 L, which is equal to 3. So L value how much now here, that is 3 by 100. So this means we can write as whatever 30 millihenry. How much this value will come? Okay, here omega contains frequency. So this value 100 pi also there, na? This is pi L. Okay, so then this value will come it as 5. So it will be a square root of, that is 4 square plus 100 pi L whole square, which is equal to 5 square. That means how much now here, 100 pi L. 100 pi L, which is equal to 3. So that is L is equal to 3 by 100 pi. Pi value given 3 na. So this value which will come to be 10 millihenry. Next, a capacitor of reactance 4 root 3 and a resistor of resistance 4 ohms are connected in series to an AC source. Peak value given. The power dissipation in the circuit is a capacitor and a resistance which are connected in series. Resistance and then capacitance. They connected in series to an AC source. Peak value given. The resistance value given as a 4 and this is given as 4 root 3. And the peak value they given as 8 root 2 they given. They are asking to find what, tell me now here. Power dissipation. Resistor only will dissipate the power, right? So if I say this current is I, tell me the value of current in the circuit now here. I is equal to, this is 8 root 2 by, this is the reactance of a capacitance, that is 4 minus J4 into root 3 na. So how much this value of current will come from this? So this I, which is equal to 8 root 2 by, we can see that this value which will come to be a square root of 4 square plus what element of 4 root 3 whole square. So then I value will come to be a what element of 8 root 2 by, this is square root of 4 square, 4 is outside, and then this value 1 plus 3, 2. So this I value will come to be a 8 root 2 by 4 into 2, 8. So we got this I value is how much now? Root 2 amperes. Current is root 2 amperes. Fine. Now we need the power dissipation now. So power, which is equal to what I can say now, I square into a resistor. How much now here? This is 2 into resistance value, how much now? 4, which is equal to 8 watts. Okay, they given peak value given now. So, okay, this current is also peak current only. Here we have this RMS value now. So we can write as IRMS square into R. So this is IRMS is 1 now. 1 square into 4. So this is IRMS, which is equal to I naught by root 2. They given peak value now. So this is 1 ampere only. So the power dissipation, which is equal to 4 watts only, not 8. A LCR circuit is at resonance for a capacitance C, inductance L, resistance R. Now the value of resistance is half, keeping all other parameters are same. The current amplitude at a resonance, which is maximum value of resistance. Okay, so at a resonance, inductive reactance, anyway at a resonance, inductive reactance, capacitive reactance is nullified now. Impedance is R only. Now the value of resistance is R, keeping all other parameters are constant. Now here, case 1, this is the impedance. We get this current, I is equal to what? Tell me now here, V by R, I1. Now what they did now here, now the values of resistance is R, that means R by 2. Now this current is what we can say now, V by R by 2. So this value will come to be what? Tell me now here, 2 into I1. So it will become double. Next one. A coil of negligible resistance is connected in series with 100 ohm across 120 volt 60 Hz supply. A voltmeter reads 36 volts across the resistor. The inductance of the coil is resistance. A coil of negligible resistance is connected in series with now what they given now here, a coil having the resistance, negligible resistance, is connected in series to a resistance, and they given supply, they given as AC supply, they given as 120 volts 60 Hz frequency, and they given this is 90 ohms, and this is inductance which is equal to L. Inductance is L. The voltmeter across a resistor, so this means across this one voltmeter we can treat as an ideal voltmeter. So this is VR, they given as 36. Yeah, you tell me now what I can say now. VR is a, which is equal to 90 by S square root of 90 square plus omega L whole square, and this value given into 120. This value they given us how much now? 36. And simplify and get it. We need to get this value of inductance. We should get now here. So here 3 1 3 2's now here, 3 3's and 0 12. This is tens, which will be equal to 300, which is equal to square root of 90 square plus omega L whole square. So that means 90 square plus omega L whole square, which is equal to 300 square. That means omega L whole square, which is equal to 300 square minus 90 square. So this value omega equal to 2 pi f na here 120. 120 pi L whole square, which is equal to, this is 390 into what element of 210. So this value, we will find out this value, how much will come? Root 390 into 210. So this value, so this is 120 pi L, which is equal to 30 into root 91. So cancellations now 3. So 3/4. Now L is equal to what element of here? 10. So this is root of 91 by 4 pi. 91 by 4 pi. Horrible calculations. Root 31 by 4 pi. 0.7. Okay, this is 0.76. Horrible calculation. Next one. In LCR-CD circuit, current is maximum at resonance. Yes, obviously. Current is purely. What happened here? The options. This options also wrong we got. So this thing. This is mistake. So in this case, as current is purely resistive circuit can never be less than that in series LCR circuit when the same source. Statement 1 is correct. Statement 2 is current in a purely resistive circuit can never be less than that in a series LCR circuit. Can be less also. Yes, so statement 2 is wrong. Statement 1 is correct. When a DC voltage of 100 volts is applied to an inductor, a current of 5 amperes flows through it. When AC of 200 volts peak value is connected to the inductor, its reactance is found to be 20 root 2. The power in the circuit is, we need to get the power. DC voltage of 100 volts is applied to an inductor. Current is this much. When AC voltage is applied, reactance is found to be this much. Okay, first we can get the resistance value R, which will be equal to how much now? 100 by 5, which will be equal to 20 ohms. So when they give reactance connected to inductor, its reactance means Z, which is given as peak value connected, its reactance is given as this much. Reactance, which will be a 5 plus J20 into root 3. Now, what will be the impedance? You tell me now. Square root of 5 square plus 20 root 3 whole square. That is mod Z, which is equal to square root of 25 plus 20 is 400 into 3, 1200. So how much this value will come here? Magnitude is a why this 5? Yeah, this is, and this is how much this resistance is 20 plus 20 root 3, J20 root 3. So this value is 20 square plus 20 root 3 the whole square will come 20 into 2. So which value will be a 40? 40 is the impedance. Now we need to get this value of current. I can get I value. Yes, 200 volts peak value only given by 40. So here 4, 5. So this 5 amperes, this is the peak value. Then what about this RMS value? Tell me. And which is equal to 5 by root 2. Now this power, so which is equal to I RMS square into R. I RMS square is 5 by root 2 whole square into resistance is 20. So we'll get the power as what? Tell me now here, 25 by 2 into 20. This is 10. We'll come it as what? Tell me now, 250. 250 watts. Next one. Now, for a given series LCR circuit, it is found that maximum current is drawn when the value of capacitance is 2.5 nanofarads. Resistance is 200, inductance is 100 millihenry. Inductors are given. The frequency of AC must be. Say, how much will be the frequency? Here also these options are not required. So frequency, maximum current means resonance only, no? Yes, at a resonance only. What the resonant frequency that is given as 1 by 2 pi into square root of LC. The resonant frequency, maximum current will occur only at the resonance only. So 1 by 2 pi into square root of LC. How much the inductance value given? So 100 milli. So this is 100 into 10 power minus 3. And then, so this is 2.5 into 10 power minus 9. Simplify and get it. How much will come? So this F0, which will come to be how much now? Yes, so this value will come to be 10 hertz. Check this answer. Will come to be at 10. Okay, fine. Yeah, we have finished the 25. Yeah, that's it for today. And the next class will discuss the remaining topic. All of you do like the session and share to all your friends.